Okay, so before we move to the breakouts later, we have our last speaker, Javier Moldon. And so Javier is actually working at IASSIC as a radio astronomer responsible for the scientific operations of the SKA Regional Center prototype in Granada at IASSIC, and also working on the scientific support and training activities. And yeah, I'm not sure if there is anything else that he wants me to say.
That's fine. Yeah.
Okay. So then he's going to speak us about how they achieved a fully reproducible workflow for the SK Data Challenge. There is, so I guess we will learn what the SK Data challenges are and how this solution was made and how it is possible to reproduce it. So Javier, the floor is yours.
Okay, thank you very much, Juan de. So yeah, I want to show you the workflow we developed to participate in the SKA Data Challenge 2 from the Square Kilometer Array by our team, which is Hi Friends or H1 Friends. And I want to show you more or less the context in which we developed the reproducibility part of this challenge. So these are the list of collaborators. Of course, there is the first ones are more involved in the reproducibility part, but then there is the rest of the Hi Friends team that I will present later. So the motivation and outline of this talk is that the SKA has these data challenges. I will briefly introduce them, which it's a challenge to find and identify sources in simulated data from the SKA. And of course, the main purpose of the challenge is to get a score proportional to the accuracy that you have in your identification of sources. And there is a leaderboard, and this is the main part, but then there is a parallel part, which is the reproducibility awards that were introduced in this second edition of the challenges, that was given for reproducible results and reusable methods. So I think this talk can be an opportunity to share with you the best practices, the problems and challenges that we found, and also the benefits of having a reproducible workflow. In this particular case, but in general in science. So a brief introduction, because Alex already introduced a little bit the challenges. These are preparatory activities for the science community, and the idea is that researchers, experts, and non-experts familiarize with SKA data products by simulating data and confronting the astronomers to this data and to try to explore and extract the maximum science from them. The first edition consisted of three bands simulated observations on 3 bands and on continuum imaging, and this second one introduced the frequency space, and there was the idea that the purpose was to the source finding and characterization of H1 emitting galaxies. So of course this multiplies the volume of the data significantly. So here you have an example of how this data look like. This has lies in frequencies of one of the brightest sources in the test cube, and you can see here the double peak of a rotating galaxy. I will not go into the details, but the idea is that there were many researchers participant and from many countries, and I think 40 teams. But one key aspect of this challenge is that the participants were not supposed to process the data cube, the data in their own infrastructures or resources. But there were 8 supercomputing centers or computing facilities that provided the hardware to analyze this data. And this is how things will happen in the future in the big data area. For example, SKA and the SKA regional centers, that is where the science is going to be done, and the data products from the SKA are going to be exploited. The it working by computer is no longer valid, and you need to create workflows that are flexible enough that maybe you can test and develop in your computer, but in the end they will need to be executed in large infrastructure. So flexibility is a key point on the future exploitation of data, astronomical data. Let me skip this. So the Hi Friends team, I will present briefly. This is the original team. It's a multidisciplinary team with experts in many different fields, from H1, galaxy evolution, computing, open science, machine learning, etc. And what we chose in the end to manage the workflow was to use this workflow management system called SnakeMake. It's something similar to Make, but it's the syntax can be written in Python, so it's I would say more human friendly, and also it has additional functionality that helps manage the workflow. Also, of course, the packages, the dependencies of the packages you use, and also the execution itself and the parallelization, for example, if you need. And let me just comment on this briefly on this diagram that is from a paper presenting the SnakeMake package. And you see here that reproducibility is one part of a bigger picture in which the purpose, the objective, final objective is the sustainability of the code or the process or the analysis that we are doing. And of course, this depends on reproducibility, but also in adaptability, which enables other people or yourself to adapt and grow particular analysis and adapt it to different necessities, and also, of course, transparency, which is needed to understand what is going on the workflow and the analysis, and be able to understand the whole process and how to modify it. So this requires, of course, automation, scalability, and portability, which are also important for the purpose of running all this analysis in large supercomputers or HPC clusters, for example. Which also helps with the adaptability, is needed for the adaptability, but also readability, traceability, and documentation are also important in all these ecosystems. So it's not just a matter of pressing a button and get the result, but you also need to understand what is going on and be able to adapt it and improve it in some cases. So this is our workflow. It's a sketch of our workflow. As you see, it's rather simple. There is some parallelization at the beginning because the data cube is a large volume data cube, 1 terabyte of data. So we chunk the data in different chunks, small chunks, and then we process. The heavy lifting of here is run by Sophia. Sophia is a package to identify H1 sources in data cubes. So this is running also in parallel, and then some pre-processing and post-processing is done. We finally gather the results from these individual chunks, and then we post-process it, and we do some operations, visualization, and then we are finished with the workflow. And this is one of the first ideas I wanted to share. Things like this, some simple diagram that in this case, for example, is produced automatically by SnakeMake, but you can also do it manually if you want. I think it's very important to share, when you share a workflow or analysis or any type of data processing, I think it's very important to be able to visualize. It doesn't need to be an image, but visualize the dependency flow of the steps you are conducting. So let me just share some tips and tricks of things that we found while developing this pipeline. First of all, the data challenge itself, because it has this award, the reproducibility award, they release, thanks to Software Sustainability Institute, a series of criteria that were going to be evaluated for this award, and they are divided in, they are very specific steps, and they are divided in more or less these blocks. Like the workflow needs to be well documented, easy to install, easy to use. It has to be have an open license. The code needs to be accessible and following standards, and there should be some testing. And I would say that this is really important because there are many aspects that maybe you don't realize when you are producing your analysis. And when you look at a checklist like this, and you can verify how many steps are you complying with, you realize that there are more things that sometimes it's easier that you can apply. And what I like also about this is that it has like 3 levels: bronze, silver, and gold, which is already telling you that reproducibility is not everything or nothing. It can be a process, it can be improved, and it can be improved with time in the end. So one of these criteria was to have version control. We were using Git and GitHub as a main option. We also put some effort on the documentation. Here you can see that we describe the context of this workflow, why this was developed, and for what, in which context, the methodology that we follow, but also the workflow description, installation with different ways of installing and running it, the execution also with examples on how to do it, and then our own result from our team. So I think also another tip is that it's important that the documentation lives along the code, so it can be updated as a single block. When you change the source code, you can also change the documentation at the same time, and everything is more easily maintained. Also, of course, with version control. And in our case, we deployed these were written as markdowns here in source, and we rendered this as read the docs web page. Probably it's better to have host owned by yourself, but if not, if you don't have, this is a very easy solution. You can set up in a couple of minutes and you have your documentation rendered in a very useful way. There is also some developers documentation. It's not very extensive because the workflow is also not very complex, but basically thanks to Sphinx, the properties of the functions that are used, all the functions, the Python functions mostly that are used, is automatically documented in this documentation. So you have a brief description, the parameters and the characteristics of the parameters. So that also enables this, the idea of being able to adapt, that anyone can adapt and use this as a base to work better, improve workflows. Another important thing is file traceability. This is also a diagram that is produced by SnakeMake, which makes it very convenient. And here you have the rules, so the flow of data, and each rule has an input and an output. It's like make, it has to have a very well-defined input and output. And this traces how these dependencies are used during the workflow. This is just zooming in this region. You can see this rule has one input and three outputs. And then the visualize is producing, for example, Python notebooks, PNGs, etc. So this helps different things. First, understanding the flow, understanding where this particular file came from, who produced it, and what are the dependencies of that. But also it benefits modularization, because if you have very well defined, for example, here in this function, you have very well defined input and output, you can completely change this function or this rule in this case by something that is more sophisticated or more advanced or more accurate. And as long as you preserve the input and output characteristics, you can just change this module without changing the whole workflow. And this also allows better collaboration because people can interact easily and work in different steps of the workflow. File structure, this was also commented in Mohammed talk and also on Monday about cookie cutter. So we were following a workflow file structure also suggested by SnakeMake, in which the whole workflow is contained in one single directory with EMS, where we host the Conda environments. All the software in this case is installed by Conda, managed by Conda. So each of these rules have individual Conda environments. So that means that we can keep them simple and small and also modular. This is a template, and this is very small because it's just an empty template that is used to produce the final notebook to visualize. These are the rules, so the workflow itself, and these are the scripts that are used by these rules. One rule can use one or more of these scripts. And also the file structure for the results. In this case, we were dividing the results in catalogs, logs, notebooks, plots, and the Sophia interim products. And as you can see, for example, the logs also have a very well-defined structure with rules, directories for rule, and then for each job execution. So it's very easy to find the log corresponding to exactly the step that you are interested in. So I think this is also a good benefit of using management systems like this, that you can have the structure, or if not, you can define it, of course, very, very easily. The software provenance, in this case, this workflow management system produces this report in HTML with the input files, output files, and then the versions of the software that were used by one particular rule, in this case, this rule, and also the code that was executed. And because you have the code of the script, you have, in principle, everything that you need to reproduce this. The only problem is that SnakeMake in particular does not provide provenance in a standard format. We were talking just a few minutes ago about provenance format. But if you want to contribute, for sure there are many people in this conference, in this workshop, that knows a lot about this. There is already an open pull request, which is number 1, but it has been stuck for some time. So if you want to contribute and make this provenance more standardized, that would be grateful. Of course, there is also the possibility of using these are other types of files or things that are useful to understand the workflow, and people can freely approach your workflow, either to use it or just to check it or just to improve it if they want. For example, of course, the citation file can be standardized. The code of conduct, this is getting more and more relevant. This was also proposed by UNESCO, that code of conduct also in software is important for inclusiveness of all types of societies and accessibility for all types of societies. And this was based on the contributor covenant. You have the links in the repository if you're interested. Also, well, yeah, if you have the license, visually you can visually see it easily. That also helps getting people close to the workflow. Links to the documentation, to the Zenodo entry, to the. We're also following. This is another kind of checklist, the OpenSSF best practices, which is more designed for software packages, not so much for workflows. But there were many things in there that make you realize that things that can be improved in your workflow. So we were trying to follow as much as possible this kind of best practices. It's a good resource, I think. Unit tests, this was one of the criteria for reproducibility. We implemented unit tests at the rule level. So in this workflow, in the SnakeMake, we could test the rules, and this was facilitated at some part by SnakeMake. But our issue is that we started too late for a thorough implementation at the functions level. The practice would be to have tests for every function, but also, well, the challenge was limited in time, and we didn't have time to do it at that level, but at least the rules could be tested. So my recommendations are unit tests are hard to implement in reality because many people are not used to them, and because they don't have a rapid benefit. It's always the benefit comes in the long term. When you have a problem, then is when you realize that the tests are important, but in the short term, they don't. Sometimes we forget about them, or we don't spend time on them because there's not immediate benefit, but in the long term it can be important. So I would recommend start early and be progressive, implementing unit tests, keep it simple, but do it persistently, and try to cover at least the critical parts. Okay. I would also recommend having or creating an executable small example. Of course, in this case, the data cube was 1 terabyte, so nobody is going to download the 1 terabyte just to check the workflow or to see it in action. So we just created a mock data set and a very easy command with -check option that can be launched in Binder. And just with one command, in a few minutes, in a very low resource virtual machine, you can download this test data cube and execute the SnakeMake command. So, well, it's executed automatically. So you can download all dependencies, install all dependencies. That takes a few minutes, and see it in action in this data set. The results are not very exciting, of course. It's a very small data set, but you can see the whole process just happening in Binder, and also the plots describing the workflow that was just executed. We also try to put a lot of effort on having multiple options to deploy, execute the workflow. Of course, Mohamed has shown, I think, is the best way to manage all this and to execute a workflow. Well, we didn't have time to implement. It would have been very good, but we didn't have time to implement that solution and to understand it in profundity. So at least we have these options, several options. One of them is just running a SnakeMake. You can install SnakeMake, and then it will manage all the dependencies and install all the dependencies and run the workflow, and also the parallelization and everything. So it's very convenient. In case the software repositories with the dependencies are not available, imagine Conda Forge or Anaconda or anything, the dependencies are also encapsulated in Zenodo, so you don't need to access remote servers apart from Zenodo to get them. Docker files, we gave instructions to build images, Docker images that you can build yourself. That means that you can adapt them if you need, or also the Docker image available in Zenodo in case you don't have, for example, root access to some machine. You can also just download the image. And the same for Singularity, build the image yourself or use the image in Zenodo. We also included instructions to build with Podman, and also the link that I just showed with MyBinder for verification purposes only when you're using MyBinder, of course. This is just a snapshot of the Zenodo repository. Of course, it's open access. It has a DOI, and you can track the history of what happened here. And the repository includes several things. This is a copy of the GitHub repository, so the one that we use for the solution. This is the self-contained workflow archive that contains also the code and the dependencies of all the packages that are used. And then we have the Singularity and Docker images, and then our particular solution. We are differentiating the workflow itself, which is very minimal, and the solution that we produce, our particular solution. Okay. For accessibility, there are other registries also. We discovered this workflow hub that I think it has not been there for long, at least. I think this was the first or the second workflow ever uploaded based on SnakeMake. And also I discovered a few weeks after submitting it that SnakeMake has this automatic way on localizing workflows in GitHub, for example, and I think also GitLab. And it creates a repository of a catalog of workflows based on a SnakeMake. And because we were following the structure, the defined structure for the recommended structure, it was identified and automatically classified as a workflow in the catalog. Okay, just some final notes to finish. I think, well, first of all, reproducibility is hard. Doing everything that you would need to make it an analysis reproducible is hard, but it's of course necessary for open science. So I think that we need to put a lot of effort on a strong community, and because it's hard to manage all these systems and all these dependencies and everything, and people usually don't have time. I think training the community is also important. If we learn something, it's always good to share it with our peers, because the strongest the community, the most impactful will be open science and reproducibility. So we are coordinating some training activities, mostly in our institute, but also in other places. For example, these open science droplets are hands-on demo, very short demos on some of these tools. PySnacks that we are currently running, it's a focused training on specific Python packages, so people can understand them. We are also, just yesterday we finished a course on tools for the reproducibility of scientific analysis, and the contents of these are based basically in what we learned during this reproducibility award, well, the data challenge. So all the tools that we were discovering, now we are explaining them in this course, like a SnakeMake or Read the Docs, all these things. And also, as Alex also mentioned yesterday, the SKA training hands-on on containerization. I think that's also useful to at least help people get familiar with some tools that are available. So just some final thoughts. I think SnakeMake is actually useful and fun, and that's beyond reproducibility. It's useful because it helps yourself. So that's a good thing. This kind of workflow management systems help people do better work, or easier work at least. So I think not in particular SnakeMake has something special, it's just because I used it, but there are many. In fact, I think there are too many workflow management systems, but this can help. Reproducibility is fun because it is science, but it's also hard, and it requires a lot of time, and it requires learning new tools, new methodologies, and not everyone is willing to do so or are seeing the perspectives of that. The benefits of that. So I think that it's important that we promote progressive reproducibility. I like very much these bronze, gold, silver, and gold levels of reproducibility, depending on how much time you want to spend doing all those things. So in the course we just finished, I recommended to the participants that even if they just have a README file in a version control environment, that they explain what they are doing, how they are doing the analysis, and what tools are they using in the versions. Only with a simple README is a good step. So it's we need to start with something, and this will trigger more and more complex reproducibility workflows. So I think that's an important message for people that want to start doing their science more open and more reproducible. And also sharing these reproducible methodologies, I think is an excellent way to engage future adopters, because when you see something that is done and works, you may get ideas. So, okay, I want to use this, or I want to use that option, or I want to use that methodology. So I think that's also something that can only help other people. And just the final thought is that training and community building, I think, are essential for open science or for reproducibility. And that's all I wanted to present.
Thank you, Javier. Also, I'm very pleased that all the speakers today have gotten into their allocations and even made them shorter, because this allows for time for more questions. Are there any questions from the audience? I had one, if nobody asks. Yeah, Pedram says that this idea of progressive reproducibility is a nice thing. I would argue for an additional level, something like wood kind of metal, which means that you've started. I think recognizing that you've started, even you have not reached something that could be worthy of a medal, might be useful.
Yeah, for sure.
any more questions? If not, I'll make my own. So why going with snake make versus make? It's because of the graphical visualizations, additional tools, or are they more readable? What's the reason for that?
I think it's not for the graphical thing. That's something that is like an add-on for the final thing. In my case, I think it was because I started to use using Conda environments and also Docker files, Singularity files, and then I found that it was very easy with SnakeMake to integrate all that in the rules, and then you can define your environments and everything is automatically set up. So I would say that there is an interesting talk that I think it's from the Common Workflow Language, which is another workflow management system. And it starts with the talk saying, okay, these are some management systems. And then there are like 6 or 7 pages with 200 management systems. So I think that there are for all purposes and all for everyone there is a workflow management system. So I wouldn't recommend especially this one, but I find it easy and easy. So there are not many barriers. It's because you are using Python anyways. Many people are already used to use code in Python, and so the barriers to start using it they are not much. And I find it more human friendly that make. So I think that can be helpful for people. It was helpful for me, for example. So I think it can also be helpful for other people. For example, you can specify where the logs should be kept, and then it will manage to keep them organized. All those things are useful. More small things, but they are useful. And it's also compatible with cloud computing, with HPC, and all these things. So that makes things easier also.
Okay.